All right, so this is question 1 from the most recent exam I sent you. Maybe this is the one you're thinking of. Are you able to see my screen?
Yes.
Okay, so it asks for the graph at x equals 0, and here's x equals 0, right there at the origin, but it's down here somewhere. This is a graph of a parabola. So there's really 2 ways you can describe the graph. One is in standard form, and the other is in vertex form.
Okay.
So depending on the information you're given, one is better than the other. I mean, I think when we were doing lessons for your algebra one class, we might have covered this. The vertex is not given, but it looks like you could figure that out, like if you wanted. So that would be one reason to use this. There's even a third form here, which is the factored form, x minus the 0, x minus the 0 times a. And that one works really well when you have the zeros here.
Okay.
So you got to, and I guess I could look at the solution here, which I haven't looked at in a while, but it probably, this one I think focuses on using the intercept form of the quadratic equation.
Okay.
Which is
So
not, well, that's not actually, I see why that might be an issue, because it's not, well, I guess the quadratic formula is how you used to solve it. Maybe there's some included, but anyway, the zeros are at 1 and 2, 3, 4, 5, 6, 7. So this is y equals a, x minus 1, x minus 7. And you still have the problem of you have 3 unknowns. You have this one, and this one, y, a, and x. So that's why this point is given up here. It's to help find the value of a.
okay.
So when you reduce here, you get positive 2, you get negative 4, so you get 16 equals negative 8a, a equals minus 2. And then you would rewrite the equation with that value. So negative 2x minus 1, x minus 7. The x value is at 0, so that's why it comes down into those points there. Y equals negative 2, 0 minus 1, 0 minus 7. Y equals negative 2 times negative 1 times negative 7, which is negative 14.
Okay.
Would you like another one like this?
Yeah, I think that'd be good.
Okay. All right, let me get to where I can figure out what that is. 3CS0. This is first exam. And question 24-2. Okay. All right, let's see. Projects. 20. So these are going to be in it's going to appear slightly differently because it's going to be in one column rather than 2. But that isn't what I wanted. Give me just a moment here to find it. Okay, so we're up to 53. Okay, so it's really question 27. All right, I've got a couple here that we can look at. Okay, So let me snip this in. We'll look at another question together here. These are all the same in the sense that you have to write the equation because they don't give you enough of the graph to determine that value, and you don't want to try and predict it either.
Okay.
So this is the same thing. This one does not have the vertex. That's sort of obvious here. Like it's not. You can't be like, you can't. Well, is that half? Is it minus 18.5? So the vertex form doesn't work. This is emphasizing the intercept form. So there's one at -2 and there's one at +4.
Oh, so you have to do like the y equals
Yes.
a whatever that equation
Yep.
is.
It's x minus the 0, so it's x minus a -2, and then x minus 4. And then use this point here. So y equals a, x plus 2, x minus 4. Okay, so why don't you try solving from here? Put this point in for x and y, and get the value of a, and then move through. And then we can do one where it's in vertex form.
Sure. Okay, I got well, the closest is a, but I got -16.
Okay, so the issue, this one definitely opens up. So a is definitely positive. What did you get for a value of a?
2.
2. Okay, so the value of a, let me just check that. -18 equals a times 2 times -4. Oh, I'm sorry, when x is 1. So that's 3 and -3. So -18 equals -9a, so a equals 2. I agree with that. So you rewrite this as 2 times x plus 2, x minus 4.
Right.
Okay, so this is a mistake here. I guess I didn't there's an error in 1, 2, 3. Oh, I'm so sorry. This is all wrong from the beginning. This is 3. This is 3. Let me just restart this and work through it. I gave you the wrong intercepts because I didn't count correctly, and that makes a huge difference here. So let me just
So
get
is
this.
would it have been -16 from what I did?
Well, it would have been 0 because when you multiply 4 minus 4, that's 0.
Well, don't you
Uh,
put in 0 for x? So
you're checking it at 4. You want to know the value of the function at 4.
Okay.
So all kinds of mistakes here, but this is a, x minus a -2, and then x minus 3. So that's y equals a, x plus 2, x minus 3. So we have this point, -18 equals a, 1 plus 2, 1 minus 3. So we end up getting -18 equals a times 3 times -2. -18 equals -6a. A equals 3. So then that's plugged back into the equation. Y equals 3x plus 2, x minus 3, and then you're substituting in x equals 4. So you have 4 plus 2, 4 minus 3. So that's 3 times 6 times 1, which is 18. Let's do another one where you actually use the vertex, because that may be the way that you're thinking of doing this question. So let's try.
What have we been using so far?
It's called the intercept form. It's just writing the zeros. It's what, if you recall, you had some exams where it would say like the factors of the polynomial are or the zeros are at these different numbers, and you write x minus the number, x minus the number, x minus the number, and so on. We're doing that here, but this one we'll do in vertex form. So we have to find the vertex. So you got to count here. This is 1, 2, 3, so 3 down. And then if you start down here at negative 12, 13, 14, 15, 16. Okay, so that's totally reasonable. And if you recall, the vertex form is x minus h squared plus k. This is h, this is k. So we're gonna write y equals a x minus 3 squared minus 16. So notice though that you still have 1, 2, 3 unknowns. You still have to use this point 2 comma 12, 2 comma negative 12 as your x and y to get your value of a. So that's negative 12 equals 2 x minus, I'm sorry, a is not 2, x is 2, a 2 minus 3 squared minus 16. So you have to be able to resolve this. This is negative 1 squared, which is positive 1. So the more you can do this without having to write it down. So if you just add 16 to both sides, you find that a equals 4. And that makes sense because it opens up a should be greater than 0.
Okay.
So now, again, like, okay, well, what do we do? That's not the answer. That's just the value of a. A lot of these questions are synthesis multi-step questions. They want it at 7. So you have to put 7 in, or I want it at 7. 7 in for x. So 4 times 7 minus 3 squared minus 16. 7 minus 3 squared is 4. 4 squared is 16. 16 times 4 is 64. The more you can do that, again, that's going to really save you quite a bit on that. So let's do one more. I provided a lot of sort of explanation. Let me have you do one more. Let me find you one here where the vertex is shown. All right, so okay, so let me just make this a big. Let's take about 60 seconds and have you work on this. All right, go ahead and get started, please. How are you doing on this one?
I'm almost at the end, I think, but I'm
Okay.
getting kind of a big number, so I don't know.
Yeah, I intentionally didn't put the multiple choice there. Are you comfortable sharing your final answer?
I got 32.
You're correct.
Oh, really? Wow.
Yeah. So it is so based on some of your feedback, I'm incorporating more questions now with non-multiple choice on these practice tests that I work with students because it's you if you've done the steps right, the answer is 32. That's totally reasonable, and it's certainly got to be positive, and we just don't know how far. Or actually, we're over here at -1. You're over here at -1. You're not, it goes way up there. So great. Um, so let's move back to the book here. We'll see some repeats, some not. Um, let me yeah, let's just run through it. Is there any other questions that you'd like us to sort of work through specifically before I do this?
No, I think I'm good. That was the only
Okay.
one.
All right. I'm pretty sure you've seen this question before, so I think this would be a good one for you to try on your own, at least initially,
Okay.
and then I can sort of help if needed. But I'll read it out loud. So, bakery in Minneapolis makes cakes on Tuesdays and pies on Wednesdays. Amanda can make K cakes per hour, and Marissa can make T pies per hour. Amanda only works 11 hours on Tuesdays, and Marissa only works 10 hours on Wednesdays. Which of the following expressions describes the number of weeks n needed to produce W baked goods made by the pair? So let me know if you need a hint or anything, but go ahead and give this one a try, please. So if you've done this correctly, you'll see that in 1 week they can make 11K plus 10T baked goods.
I did that. And then the total is W. So that's where I got a little stuck.
Yeah, and that's where this one a lot of these have 11K plus 10T. That one looks okay. This has got 11K and 10T. That one looks okay. This 10K plus 11T,
No.
no, and it's kind of same thing down here. That doesn't help you though. I mean, that gets you down to a guess, which I mean, okay. So I made this. So in 2 weeks, let's look at it differently, as it doesn't tell you in 2 weeks how many baked goods do they make. Well, it's double what they make in 1 week, and then in 3 weeks, it's 3 times the same expression. So what about in n weeks? What would that look like? It looks like this, where you have the number of weeks times however many they can make per week. So the total number of baked good is actually over here, W. So how do you solve this for W? What's the math operation here? I'm sorry for n. I spoke. How do you solve for n here? What is the math operation?
Multiply.
Divide. Divide both sides by 11K
Oh, to get
plus
n.
10T.
Yeah, right.
So you will always, I mean, my experience is based on looking at these practice materials, is you will always get a question where the answer is an expression like this. Seems to be a common approach. Okay, would you like to work on another one like that? I think I would suggest skipping that. I don't think it's super. Okay. All right, so let's move to a numerical problem here. All right, so this question, it's pretty straightforward. It gives you an equation at the top here. It gives you some values, and it asks for the value of 1 over a. Your choice before you solve this is you can put this in for k right away,
Okay.
or you can try to combine all those on the left-hand side into a single expression. There's no right or wrong answer, but right or wrong way to do this. But which way are you kind of leaning when you see this?
Probably plugging it in.
Okay, so let's do that. So you get 1 over 5 times 1/2 minus 1 over 1/2 minus 1 over 2 times 1/2
Okay.
equals a. And as I mentioned before, the more you can do this in advance, the better. So for example, like this right here becomes 1 over 5/2. So if you can immediately see that that's 2/5, you're in really good shape. This one becomes 2. This is 1 over 1, which becomes 1 equals a.
Okay.
So now what do you see doing here on this left side? How would you simplify that?
Just make common denominator.
Yeah. Now this is -3 and this is 2/5. So if you can go to minus 15 over 3, that I'm sorry, minus 15 over 5, that saves you some time there.
Okay. So
If you can see that. So the more you can sort of jump steps really helps here. So this is minus 13. Oh, I've got an extra 1 here. I'm sorry. It's really unclear. So this becomes minus 13 over 5 equals a. Is that what it's asking for? I mean, it's there.
no, because it's 1 over a. So you have to do 1 over negative 13 over 5.
Yeah, or you have to, or it's just the flip of this. So 1 over a is 5 over negative 5 over 13.
Oh, okay. So that's okay.
All right, so let's do another one like that because it will really help here to it will really help to kind of get this skill put into place. So this is question, what do I got here? Math skill 15, fork 1. All right, so let me snip this next one in. So the last problem, the reason it worked out well to substitute the answer in pretty much right away is that it kind of cleared out a little bit. The same thing kind of happens here. When you put this 5/3 in for k, it works out well there because you're multiplying by 3 and it ends up clearing the denominator. Over here, you just flip it, so it works out well. But then the middle one, you get a fraction to deal with. So let's write it out here. It's -1 over 3 times 5/3.
Sorry, what's the other way again if you don't plug in?
You combine all these and then you only have to substitute it one time. So you combine the fractions here.
Can we do this one that way?
Sure.
Just so I can see that.
Yep. I think that's good to do here. So let me get to where I just grabbed this and then I'll restart here. Oh, that didn't snip very large. Okay. I'll just scroll down here. So the common denominator here would be 12k.
Right.
And again, the more you can do without writing, like to get to 12k, you have to multiply top and bottom by 4. So this becomes -4 over 12k. This one in the middle, you have to multiply the top and bottom by 3. So this plus goes with there, so this becomes negative 3 over 12k. And this one you have to multiply the top and bottom by 12, so it becomes minus 12 over 12k equals a. And our k value is 5/3 as a reminder. So this rewrites into minus 19 over 12k, but instead of writing k, what if we just substitute that in here to save some time?
Sure.
So notice down here you have a choice. You can multiply and divide, or you can divide and then multiply. If you divide, 12 divided by 3 is 4, times 5 is 20. So this becomes minus 19 over 20 equals a. And then 1 over a is 20 over 19.
Wait, how did you get minus 19 over 20?
12 divided by 3 times 5. This is 4 times 5 is 20. I know that the way that you generally do this is 12 times 5 divided by 3, which is 60, divided by 3, which is 20. So doing it this first way, you reduce the size of the numbers. That's why you generally divide before you multiply, and for speed, because it creates smaller numbers when you can.
Mm-hmm.
So then that bottom part becomes the 20. This becomes the 20. The minus 19 stays. And then once we want 1 over a, it's minus 20 over 19. Which is interesting because the answer appears to be wrong. Did I make a mistake somewhere? 7 minus 19. Nope, but there is actually a mistake here in the solution. So
Wait, you need a common denominator to multiply, right? Or is it only to fractions?
just to add or subtract the fractions, you need a common denominator.
Okay.
All right. Okay. So let's do another one here. This time, though, I will not show the solutions. That way, there's more emphasis on the work. That's one of the challenges is when you have the answers, you always sort of have some comfort in knowing whether you're right or wrong. Let's just see how this one goes. Your choice here, I want you to either substitute the value in or combine, make a common denominator.
I'm gonna plug it in.
Okay.
Yes.
This is what your first step should look like, substituting the numbers in.
Yeah.
So it looks like here you might have been better off finding the common denominator because of the fact that you still have to find one for this part of it.
Yeah. Wouldn't it be 9 over 2 and not 2 9ths?
So 1 over 9 over, so this one on the right here, this becomes 1 over 9 over 2.
Yeah.
Whenever you have the flip of something, or whenever you have 1 over a over b, this equals b over a. And that's why it becomes 2/9.
Okay, nice.
So it looks like you get 7 over 18 here equals a, but that's not the correct answer.
It's 18 over 7, right?
Yes.
Okay.
I'm actually seeing all kinds of bugs in my my code here, which is good because it's get these fixed here. Okay, do you want to do another one like this, or would you like to do what I call the related question to this, which is kind of a backwards-ish version of this?
Let's do that. Let's do the related one.
Okay, all right. So the related one here, it looks very similar, and the we'll work through one together, and then you can decide how you think you would attack a problem like this. So the here they give you the value of 1 over a, and they want the value of k.
Okay.
So the one of the problems here is you could easily, if you're trying to create 1 over a here, 1 over a is 1 over 5k minus 1 over 3k plus 1 over 2k. And now this just got a whole lot more complicated. So this time it actually forces you to find a common denominator here.
Can't you like plug in -3 over 4 equals
For a, yes, that's also a possibility. So let's do that.
Okay.
So a is -3 over 4. So that's 1 over 5k minus 1 over 3k plus 1 over 2k equals -3 over 4. You still have this issue though on the left because you're trying to solve for k, and you don't want to try substituting these numbers in of finding a common denominator. So we're kind of stuck. You kind of have to move forward on that step. So between 3, 5, and 2, what's the least common multiple of those?
No. 30, yeah.
Yeah, 30k. So that's reasonable. 5 times to get there, that's 6. This one is -10, and this is 15. All right. So this gives you ends up giving you 11 over 30k equals -3 over 4.
Mm-hmm.
So now you've made really good progress on this question, but you have to be able to get a variable out of the denominator. That's usually the challenge here. And there's options here. I mentioned before you can simplify vertically, horizontally, if you want. So like you could reduce this 30 by 2 because it goes into both. The most common technique here is to just cross multiply.
Okay.
Which is fine. That's 11 times 4 equals -3 times 30k.
So 44 equals -90k.
Yeah. Now let me just point out that if you had reduced this by 2 and 4 by 2, you would have, and you cross multiply, you just get smaller numbers to deal with, because you end up having to divide both sides by -90, and that's fine. But you actually get your answer here on the left side. Even easier. This is another example why it's better to divide or simplify before the end. I know a lot of times we wait until the end to simplify in traditional math, but here you actually want to do it as soon as possible. All right, let me find one that doesn't have a super crazy answer, and we'll and actually this next one falls into that category. So I'm gonna not provide the answers,
Okay.
and I'll just snip this one in. It's just same thing with different numbers. So give this a try here. See how it goes.
I got 15 over 6. Oh, wait, that can be simplified. Hold on. So 5 over 2.
Okay, the answer is slightly different. So let me just work through it here. Let's try -3 plus 6 plus 2. Did you get to this step here
Yeah.
with the common? Okay, so when you combine these, you get 5 up top. 5 over 6k equals 4/3.
Yeah.
You can, if you do what I'm talking about, where you divide this by 3 and this by 3, you get 2k in the bottom here. So when I cross multiply, you get 5 equals 2k times 4, or 8k. So k equals 5 over 8.
So I think what I did was that on the 5 over 6k equals 4 over 3 step,
Uh-huh.
I did I like simplified the 4 to 2 and the 6 to 3. Can you not do that? Is
You
that not?
cannot go diagonal. You can only go vertical or horizontal.
Okay.
Top and then horizontal on the bottom.
That's where I messed up then.
And you can go vertical on the left or the right.
So when can you go diagonal? When you're
Never.
really? Oh, wow.
Yeah. Yeah. The answer you gave me was not in the multiple choice space. So the yeah, you might have you might have looked out here. Okay, here's one more. Oh, this will be the last before we move to a new problem. All right, so same thing.
I got 3 over negative 25.
This one doesn't work out great. Did you get negative 9 over 50 at some point?
No.
Okay.
I got 6 over negative 50.
Okay, so probably a small error.
Or yeah.
So if you got to this step here, you should reduce this to 3 over 10k equals negative 5/3.
Yeah, I got that.
So there's
It should
nothing
be
vertical.
9. I just I just said that 3 over 3 equals 6, which is not true.
Yeah. So these are small things that when you're under a lot of stress, you can potentially mess up on an exam like this. Okay, let's move to something new.
And 9 over 50 doesn't simplify at all, right?
Nope, just stays. It looks like it might, but not today. So why did that do that? All right, so we're doing. Okay, so we've done okay, 5. This is a new question. I don't think you've seen this one yet. Okay, so let's look at this together. It's another story question. The city of Philadelphia is building a new rectangular park with an area of 504 meters squared and a perimeter of 90 meters. A road with a sidewalk runs along one of the short sides of the park, and the other 3 sides are bordered by water. If city code does not require a fence on the side of the park bordering the road, but does require a safety fence on the sides that border water, how many feet of fence must be built to be in compliance with code? So anything stick out in particular when you read through this prompt?
The area and perimeter.
Right, so what shape is it in?
A rectangle.
Rectangle, okay. And it specifically said that there's a sidewalk on the shorter side, and we're going to call this a short side. So we can even label it as such. And the other 3 sides are bordered by water. So there's water there. Which sides have a fence?
Only the short side, right? Or no?
Yeah. So this actually this should say sidewalk, but yeah. So there's fencing. There's fencing here, and here. Okay, so how many feet of fence must be built in order to be compliant with the code? So let's call let's call the short side X and the long side Y. Is that okay?
Mm-hmm.
What does X times Y equal in this problem?
504.
It's the area, right? And then the perimeter of the park is 2X plus 2Y, and that equals
90.
90. Okay. So this problem is just a variation on the one where they say if the fence has an area of this and a perimeter of this, find the length of the sides. Okay. So do you recall how to solve a problem like this, where you have these 2 equations, this one and then this one?
Substitution?
Yes. Very good. Yes. So this one actually, if you divide both sides by 2, you get X plus Y equals 45. And then Y is the variable you generally solve for. So you get 45 minus X. So you have X times 45 minus X equals 504.
Okay, so then 45x
Minus X squared equals 504. And then generally you move everything over to the side where it's positive. So we're going to move everything to the right. So that's X squared minus 45X plus 504 equals 0. Okay, now where do we go? What's the
So you move the 504 over to the you subtract 504, right?
well, you have options here to solve.
You could factor.
You could factor. Now the factoring is not that easy on this one, and it's intentional because if you don't have nice factors, or if you have nice factors, I mean, it makes the problem pretty straightforward. So this is kind of one of those where I guess I would tell you, I'm just going to give you the factors because we're not emphasizing that. But you want to be really strong with your factoring. So it ends up being
Or could you
21.
quadratic formula?
Yeah, but without a calculator, that's a little bit much to expect you to do. So x is either 21 or 24. So which side did we say was smaller? We chose that x would be the shorter side.
Mm-hmm.
So if x is the shorter side, okay, how do we find the longer side? We have to go back and use one of these equations. So like, for example, here, we know that they must add up to 45. So that means that y is 24.
So you just do 45 minus.
So they want to know how many feet of fence must be built in order to be in compliance. So you have to figure out the fencing along these three sides, which is one short side and one short side up here and two longer sides here.
Okay. So you do 24 plus 24 plus 21 basically?
Yep. Which is 69 meters of fencing.
Okay.
Okay, let's review how you might have factored this by hand, because that's sort of a crazy, this one's pretty tough to do. The 45 helps you out. Like, you know, factors of 504, like 1 and 504, that doesn't help much. So because these numbers here have to add up to minus 45, so you have to consider that, well, that one's out. You know, 2 and 252 are out.
You need the
Okay.
ones that are closer.
Yeah, basically you would start closer together. So if you had a calculator, you would you probably, if the number was truly this big, you would get a calculator. There's variations on this question where you know they're reasonable, you know, 8 and 9 kind of thing. But that's how you would do it, and you'd figure out which ones were 20, 45 apart to be able to do that. So we are out of time. You've got this by email. I would definitely spend a lot more time on this test, working through it. We can certainly pick up here next week or whenever we meet again to work through problems. So I'll send out the notes here with today at some point.
Okay.
And thanks again for scheduling.
Thank you.
See you next time. Bye now.
Bye.